Take a breath.
Hello, everyone. Welcome to another community call of Memgraph. Thank you, everyone, for joining. We're really excited about this one. And with me, we've got the company and basically the co-founder, CTO and CEO of a company called Previsant, Doug and Satya. And basically, the problem that we were going to talk about is the problem that we're now facing with AI. So you've got Gen AI running in one corner, and then you also have various kind of agents that are run by various other teams. And those are kind of separate. Those are sometimes disconnected. And we want to basically connect them. We want to wire them kind of together to make sure they work in production. And that's exactly what Previsant kind of has done. And they built the tool, basically their platform, adaptive intelligence platform, where Memgraph is a part of it. And today, their co-founders, Satya and Doug, are going to walk us through kind of the full architecture and show a working end-to-end product. The really cool thing is that it won't be a one kind of domain kind of demo, but we'll slide across kind of multiple domains. So the patterns will definitely be directly relevant to a bunch of people. So without further ado, let me hand it over to Satya and Doug. Guys, take it from there.
Very good. Well, good morning, Satya. And while Satya is opening up, just very quickly, I'm Doug Ramsey, the co-founder with Satya and CEO. And again, Satya will start off with some presentation components, and then we'll dig into the demo. But yeah, we really appreciate you all taking the time. I know it's evening for most in Europe, so appreciate you all taking the time. And I'm based in Omaha, Nebraska. Satya is in Chicago, Illinois. But from there, take it away, Satya, from a share screen perspective.
Yeah, thank you, Doug. And Satya Sachdeva, as I think Marco mentioned, we have built adaptive intelligence platform, and we'll walk you through how the whole platform brings together different technologies, including graph database, Gen AI agents, and even structural data from relational databases through MCP server. And using that whole platform, we'll show you how we have built first of all, a graph-derived application that supports multiple domains. Today, we will look at insurance domain, which Doug specializes in, and will walk us through how some of the use cases help a specialty insurance company. And then the second demo that we will look at is the cross-system data lineage, as data flows from source systems to data warehousing or AI environments. And then we'll have some time for Q&A. So Doug, you want to talk about how our adaptive intelligence platform came about from payment integrity solution that we have?
Yep. And Satya, can you bring I'm not seeing the deck just yet. Can you bring that forward?
Oh, you are not seeing it?
Nope.
Oh, that's strange.
Yeah, Marco, maybe you can maximize that again for us so we get off on the right foot here.
Yeah.
Oh, yeah. Here we go.
There we go. Now we can see screen, Satya. Whoops.
Okay, now you can see the presentation?
No, we could for half a sec, and then it went away. There we go. Perfect.
Okay.
Now go presentation mode if you could, Satya.
Yep. Sorry about this technical glitch. Yep.
No worries. Yeah, so I think what we wanted to impress here is that this started from a payment integrity and healthcare solution, and it's really, we won't go through the details here, but if you see the picture on the right, it's a waste and abuse problem where we're using a combination of artificial intelligence, LLM, and graph database, Memgraph, to really do rules extraction. And in in our case, here in the States, we have the Medicare and Medicaid system, or CMS as it's called, where those rules are really handled or expressed in unstructured data within documents. There's some level of semi-structured data. At any rate, the process for us was to use the platform, the capability to extract those rules, and then from there be able to use the resulting data asset to do waste and abuse detection. Really the foundation for this, or where this came forward. So as we worked with Memgraph on this, we realized, hey, this has a lot of applicability to other use cases, and hence we are where we are. But we wanted to, and that's how we evolved into the adaptive intelligence piece as well. But we just wanted to share this this piece of background in terms of context. Okay, and Satya, we can go forward from here.
Yep. Okay, so these are the, as I mentioned before, bringing together various technology components together through adaptive intelligence platform. So on the left-hand side, you see Gen AI, which has been in the news and is at the top of the hype curve for the last 3-4 years. And then graph database, here we are using Memgraph. And on the right-hand see a lot of AI agents, and then 70% of organizational data still resides in relational databases. So the challenge before us was to bring all these things together. And that's how we used MCP server, and we built adaptive intelligence platform to bring all these technologies together. As Doug was mentioning, our first use case was to ingest thousands and thousands of healthcare documents and ingest them into Memgraph database. And from there, look at conflicts, overlaps across documents in terms of very complex rules, So that was our first use case. And then we brought in relational data, which is claims data, and we combined the two together to identify waste and abuse use cases. And that's how I think we began to build adaptive intelligence platform. So when we built our adaptive intelligence platform, we realized this could be used for a lot more things than just healthcare platform, And that's how we generalized it to build what we are calling as knowledge graph, which is basically a graph RAG application. It brings RAG and structured data together and then helps you do RAG queries, graph queries, or hybrid queries, And then we also use the same technology to build cross-system lineage, which I'm sure you all have faced as part of your information technology projects. How do you do impact analysis? How do you trace data as it travels from your source systems to your analytical systems or to your AI platforms? And then we also built, AI governance, and that helps you scan AI being used across the organization and then build a complete graph system to help identify where the risks are and how inadvertently some of the users may be sending your PHI or sensitive data out, So these are the 4 major applications that we have built out of this adaptive intelligence platform. So we'll first look at the capability through knowledge graph, which I mentioned is a graph RAG application. I'm sure all of you have heard the term graph RAG, but the way we have implemented using Memgraph is very interesting. So we have provided multi-domain support, and what that means is that there is a drop-down box which helps you pick whether you want to do it for insurance, retail, manufacturing, or any other domain. And then based on that domain, you can actually define the schema that Memgraph should use to populate the graph database. And then the second capability in that application is document ingestion. You can ingest, PDF files, Word documents, text, and CSV files if required, And then we have three query modes. One is querying just against the documents, meaning the documents are also ingested in the vector database, so that if you want to query just against a given document without using the graph, you can do that. But once the graph is populated and you want to discover conflicts, overlaps across series of documents, then graph becomes very handy and becomes a very good use case for helping you identify relationships and traverse those relationships while helping you identify conflicts and overlaps across documents. And it also helps you do arithmetic if you have numbers embedded in documents, or if you want to compare, for example, some of the rules against your structured data. So you can combine the two together for what we call as graph queries or hybrid queries. You can also explore the knowledge graph using Memgraph's UI interface. And then we also have provided capability to configure which LLMs you want to use for using embedding models or even for querying models. So we have provided all those capabilities, and you will look at those in a few minutes. Here is the overall architecture. We start with documents or structured data. Then we have the ingestion engine, where we can use any of the local LLMs, like using OL Llama for extraction of specified entities and relationships. And they will be both populated in the graph database, and the document chunks will be populated in the vector database. So that is a key part of our engine. We have both vector database as well as graph database. And then when we do the hybrid queries, our queries go against both the vector database and the graph database. And then we have the LLM layer, which helps translate the queries into cipher if the queries have to go against graph database, or natural language queries that will go against vector database. And that's what gives you the capability to run RAG queries, graph queries, or hybrid queries. And at the bottom you can see we are using Python, Fast API, and Unicorn as our front end, Memgraph as the database, and then Chroma DB is being used for the vector database. And currently we are using Azure OpenAI or OL Llama for querying. Now, sometimes the question comes up, why RAG and where does graph database fit in? I think in our experience, graph database plays a very important role when you are going against multiple documents and you want to discover the relationships among those documents, at the same time trying to identify if there are any conflicts or overlaps. And it helps you very easily traverse the relationships from one node to another, and it makes the task of extracting actionable information out of those unstructured documents and being able to easily relate them back to your structured data, which is our original goal, bringing structured data from relational databases together with graph database and leverage the power of Gen AI and AI against the combined structured and unstructured data.
Yep.
So Doug is going to walk us through the insurance use case. So Doug, can you see the slide and talk about it?
I can. Yep. So again, in terms of background, we probably should have said this up front, but to Satya's point, at this point, I'm probably on the wrong side of 35 years of experience in financial services, insurance, including PNC and healthcare. So that's a big part of our background. And most of that time has been spent on the data and analytics side. Most recently, I was SVP of data science, decision sciences at Mutual of Omaha here in Omaha. Prior to us, founding in 2021 roughly. And then Satya and I actually go back almost 30 years in different, incantations in different roles in organizations. But with that as the backdrop, what we wanted, based on this, we want to just illustrate this one use case. And the business context is, if you're looking for fraud or you're looking for claims research in general, it's a very document-centric type of ecosystem, and a lot of pressure on the special investigations unit to understand what's going on. Potentially, do we have fraud? How do I drive into investigations, or even identify up front not just a sampling method, but a more rational method for prioritizing potential fraud? So that's really what we're illustrating here. And the nodes, or the nodes and edges essentially are the types of documents can be anything around the claims documentation perspective as a claim submitted, anything throughout life cycle, as well as downstream. If we think about litigation management, who are the key stakeholders, whether you have a contractor, a public adjuster, potentially a litigating firm, a law firm. And these are it's a very typical workflow for a PNC or a property and casualty or specialty insurance ecosystem. And so again, the value here is if we can better understand those complex relationships between the claim itself and then the key actors, that helps the SIU really understand, do we have a problem? Can I do research much more quickly in a natural language way? Can I understand where we have clusters, patterns that occur? All of those things are kind of part and parcel to what a graph database solution brings forward. So that's with that, that's essentially the context for this solution here, and this particular use case using adaptive intelligence. So with that, Satya, I think we want to just flip to a quick demo.
Yeah. So before I think we do the queries, Doug, that you want to do, let me just walk everyone through that. So as I had mentioned before, here is the ingest capability, which can, do append to the graph or, replace the existing graph, And then when this is going on, you can see we have the logs created here. So whatever our ingestion progress, you see the logs, or if there are any challenges in ingestion. Here is the querying capability. We have 3 options: RAG, graph versus hybrid. And then the key point is you can, as I mentioned before, you can pick up the domain that you want to use. And based on the domain, we populate the default schema, which shows the entities that you want to be captured from your documents. The relationships, the synonyms, and synonyms means, policy holder is the same as insured person, So that when the data or information is being extracted, both the policy holder named insured, whatever they are being used, they will be populated in the insured entity or node, So that helps you, and you can also look at the raw JSON format of these schemas, and you can delete these entities, you can update the schema right here, and you can add new entities, and we come up with default entities and schema for example, finance or healthcare or manufacturing. So that's a real cool feature. And then we have the configuration aspect. So you can configure, where your Memgraph is located. For example, default here is 7687 port, where ChromaDB is being used from, what LLM we are using, LLM provider, both for querying and for example, LLM extraction. And And you can save these settings very easily here, and you can test them each. And then here another key feature of this application is you can even have the prompt fine-tuned, and we can have a default prompt which will be used to extract information out of the documents and used to populate your graph schema. And then another feature that we have built here is you can look at the graph view, or you can look at what is stored actually in the vector database. So how your document has been chunked, you can very easily view, and you can fine tune all that. For example, the document that Doug is going to use has been divided into 17 chunks. Or if you look at the graph database, what entities are being stored here, it shows you that. And you can also go, of course, to your Memgraph UI, where you can see all the relationships and you can traverse them through as you like.
Exactly.
And then when the system is ready, it shows you the green buttons here. Memgraph is connected to the application. ChromaDB is connected. Here in this case, Azure OpenAI, Gen AI is being used. So we are going to show you guys some queries. Doug, you can still see my screen?
I can. Yep. Yeah, and I think go ahead and cut if you want to paste in, Satya, and I'll just give a little bit of context. But I think what we're trying to illustrate here, first of all, full disclosure, we have cleansed data. This is synthetic data that does not have actual names of anybody for obvious reasons. So that's one. We want to be clear on that. But we're really just going to ask varying degrees of like 3 or 4 questions around what documents are included, what could be missing, what supports or contradicts the carrier's position, and then move into a little bit more of the legal research aspect that we talked about. So I think the first question we want to poke at, Satya, is, what carriers support, or excuse me, what documents support the carrier's position? So it's essentially help me understand what we have and don't have without me having to meticulously read through the paper-based documents or sometimes e-based documents in the first place. So that's the first component. And Satya, I think you have the results set back up.
Yep.
And just in summary here, we won't read through this, but at the end of this, it really, and I'm just going to peruse the summary component, but it just gives you an idea of what specific documents are there. So, we have a reservation of legal rights letter, wind-driven rain limitation endorsement. So these are all things about the coverage, the specifics of the claim itself that let the researcher, adjuster / special investigations individual kind of get anchored on what do we have here, right? It's a baseline of what do we have in front of us. So that's the essence of question number 1. But again, the point is it's very obviously the benefits of a chat-based interface are super helpful. For the
and it
second
also shows a cipher query as well as sources where the information came from. So.
Yep. All the appropriate documentation, and that's a really important point, Satya, too, in terms of the need to have audit balance control or audit traceability for explainability of any decision. That's a really key feature, and we see that in healthcare all the time. It's very important in P&C as well. So I think that's a great call out. The next one is really what evidence supports or contradicts full roof replacement. So this is helpful in the sense that it's starting to not just inventory what we have, but come up with some active intelligence around what do we have in front of us and where do we stand. Again, it's still basic preliminary research, but having that ability to infer, understand what we do and don't have is really an accelerator for the investigator. And I think you can see sort of in the conclusion here, it lists what the strong evidence is. There's strong evidence for a full roof replacement report. However, there's some contradicting evidence that says, the engineering report, carrier's coverage analysis, policy exclusions, etc., may be contradictory to that. So again, the ability to understand a baseline and ability to drive into which documents I might need to research further are a huge accelerator. Again, all driven by the ability to kind of understand across documents what we have in our hands. And then the next piece I think is really fascinating, and we probably learned. We suspected the hypothesis coming into this is we could really infer some interesting things from graph database, and I think we were, very happy with some sort of the outcomes. So the key piece here, the legal question is, and we have a couple of flavors of this, but what the carrier side interaction is really trying to understand, do we have a network that's out there, but that exists where we have a common legal firm or law firm, public adjuster and contractor, which, by the way, is not illegal. There's nothing unethical or illegal about those groups working in concert with each other, but it can be if it's abused. So that's sort of the perspective. At a minimum, the carrier wants to understand where those networks, and they can be called, claims amplification networks, but where those networks exist, who the players are. So what we got back in this next one, like who are the major players, the stakeholders on the plaintiff side. We have information about the clustering that's occurred, the referral patterns, understanding who the key players are. And you can see some, again, synthetic names, but the Maddox Keene Trial Group, Harbor Peak Claims, the public adjuster, etc. And then a contractor. So understanding that context is really important. And the next step as you go further then is to say, okay, this could be problematic. Let's at least, that insight at least drives the team's ability to frame a litigation strategy in these, especially if there are large claim cases and specialty. Or it also is potentially the opportunity to say, I want to dig one step further, which is really the last question, which is, hey, how can I quantify and ultimately understand, is there a pattern of behavior here based on the methodology used, the abnormal claim amounts, the amount of time that this claim takes to close, et cetera, that would be grounds for pushing back and saying, hey, this is potentially a fraudulent activity. And fraud's a strong word, but let's call it a wasteful or abusive activity on the plaintiff's part. So that's ultimately, these are just really good examples of how the tool itself and the technology can help us understand disparate data structures, understand patterns that we may not have understood otherwise, or would have been difficult to figure out without this kind of assistance. So, we could call this augmented intelligence. I know that term is getting a lot of traction as opposed to artificial, but it's augmented intelligence to really accelerate and help the knowledge worker on the SIU, the Special Investigations Unit side. That's really the net of the demo components, right, Satya? I think we've demonstrated those 3 or 4 questions within the application. And I think I think we have one more panel here on just key takeaways. So we've really covered these, but the net is it does, like we've said, this persistent data layer that identifies relationships, i.e. the graph, the Memgraph data components, super important, super helpful for SIU teams. I think the other key piece is talking about cross-sector. You can certainly imagine where if we're in a compliance environment, a private equity due diligence research, manufacturing, where we're really having to ingest a lot of information about manufacturing line operations, et cetera. This type of you can certainly envision what this type of a solution is applicable, super useful in a number of different domains, right? So it's not, although we're focusing on insurance here, I think Satya's earlier points absolutely valid that there are use cases that this transcends sector, I think is the bottom line there. And there's we've seen, in fact, we've talked to FinServ compliance and private equity due diligence. There are a couple of active conversations we've had on, especially to the extent, private equity wants those types of research activities to be private. They don't want those in any way, shape, or form subjected to anything that could be considered public. So, at any rate.
And we have another use case, for manufacturing of aircraft engines, actually, where when the aircraft engines come for service, they go through detailed inspection, which can be hundreds of pages. And when we have inspection reports from different engines, we wanted to see how, some of the root causes are common across those engine failures, So this application can be very useful in identifying the root cause and repeated causes of failure of those expensive aircraft engine repairs, So,
hey Satya, it looks like we have a couple of questions here in the chat too, and I think we can address one question was, how are you able to mass classify data from each individual source? I.e., how do you label documents so that you always know X is plaintiff? So essentially, how do we know? And I think part of that is the language model itself that's going to recognize X legal firm, use language that helps identify those things.
No, actually we also have the schema definition, which I showed earlier. So the schema has entities, relationships, and synonyms. So synonyms is very critical when we are extracting information out of these unstructured documents, where we can define, hey, these three things, they all mean the same thing.
Right. Exactly.
So, for example, policyholder and means insured.
Correct. And I think we also have to recognize there's always a human in the loop element that we're talking about here. It's not just set and forget. So, and I think Charlie, it looks like you might need to jump. But we can certainly, I think Marco mentioned, we can certainly follow up with the recording, and happy to talk further on this topic as well.
Yeah, and I can just again show, you can see here very easily the schema I'm showing. And this is where we define synonyms. So for example, all these first policyholder, named insured, first party, claimant, all are canonically related and called insured in the graph. Does that answer the question?
I think so, although I think Charlie left a note and said he needs to leave. So I think maybe there's a follow-up. We can follow up on that.
Okay.
Satya. And then there was another question on the can we share the schema for legal? And Marco mentioned, yes, we will. We can do that offline in terms of what that
we can do that. Yeah.
Looks like. Yep. Cool. Okay.
Okay. So coming back to our presentation, Doug, you had any other point before I?
No, I think let's move forward. I think that this is great. And I think we're okay on probably decent on time.
Yeah. The second important application that we wanted to share was this cross-system lineage. So where the source systems could be any COBOL, Informatica, Python code, Snowflake, Oracle, even AI prompts, and we are looking at any type of code, C code that you may have from where the data is originating or being processed along the way. And then we have agent pipeline where we have discovery agent. So basically that will go and discover the information out of each of these source systems, code, and whatever else you have. For example, copybooks or schema definitions or ER diagrams or any of those kind of things, Informatica. And then we link the entities from across those source systems into common cross-system feeds through the graph database. And then we have also built in very important capability which does not exist in most of the data lineage tools today, is the capability to decipher dynamic SQL. So for example, when you have the dynamic SQL, you don't know until the runtime which table or which source system or what column you're talking about. So what we do is we go against the runtime logs to extract information at the runtime and link it with other sources of information. And then we also link it with Git, your repository or any other repository. And at the same time, we continuously monitor for any changes. So these are some of the AI agents that we have brought together. And then we store all this into the Memgraph database. And we are also able to label different types of schemas that we have stored in the same Memgraph. And in this case, we can say, okay, application label is data lineage. And then we have built a front-end UI. You can browse it through Memgraph Lab, etc. But we'll show you how you can even do natural language query using any of the LLMs publicly available or your local LLMs like OLLama, which can be very cost effective and protects your sensitive data as well. So here is how it works. So you can point it to any of the source systems, vSAM, ISAM, DB2, SAP, Oracle. Even we have tried it against Salesforce.com and any other APIs. And then we have the AI agents, as I mentioned, that will go and read all of those sources, build graph database, and then provide a Gen AI layer for impact analysis, automatic documentation, PII classification, column level lineage, and the whole journey of the data. And then business users can look at, what is the impact of changing one of these fields, or what are the conflicts or multiple paths being used for calculation of a field to get you one source of data. Most organizations still struggle with single source of truth, and this can help you quickly understand if a data is traveling through multiple ETL or data engineering paths. So with that, I'm going to go and show you the demo of cross-system lineage. So here you can see, the overview. When you log into this application, this is what you will see. It will show you the complete system, and it will show you what source systems AI agents are working and how they are coming back together. And here you can say, once you have pointed out to, for example, new source data, you can just say rescan sources, or you can say reload graph databases when you want to start from the beginning. And then here are the AI agents that show you, how they are discovering various source systems. And as the discovery happens, they will show you the progress. We have the change detection agents, the querying and impact agents, as well as the graph builder agents. And when you are scanning, you will see actual progress of each one of these. And then the graph database is where actually you can see, for example, COBOL, what are the source systems and copybooks that are being analyzed, and what Informatica processes are being analyzed, or Python on the way, or Snowflake, or if your BI environment is Oracle. This is the natural language query, which will, for example, answer your questions like, which PII fields from flow through Informatica, for this policy claim. Or what does this normalized amount do, and what field does it read and write? So you can ask any of these questions, and you can do impact analysis of how you can, when something changes, what will happen to your overall pipeline. Here you can see actual field level analysis and what processes does it go through for each of those data journey points. You can look at the flow diagram, you can look at the change history, when certain fields were changed. So it gives you complete meta for your data journey, for impact analysis, and looking at what the challenges will be or single version of truth, where the differences are and how to resolve those differences here. We have even built, a link to the graph which shows basically your relationships from your COBOL. For example, these are all the COBOL related nodes. These are all the Informatica related nodes and Python related nodes. We can even look at them in different colors and things like that. And this is the capability that earlier I was talking about, runtime logs. So basically it will look at your Oracle audit trail or Informatica workflow log and then help you understand the dynamic SQL whenever and wherever it is being used. So that you have complete 360-degree views of your data journey and not just parts of it.
And Satya, we had one question here on, did I understand correctly that you store the document chunks not just in Chroma but also in Memgraph? Do you want to address that?
Yes. So we are storing chunks of the document in Chroma, and the reason for that is if you want just RAG queries against unstructured data, that is the best option. And you can just have a vector database populated in this application, and you can do without graph database if you don't need it. So it truly works as graph RAG, where you have the RAG component, graph component, and the combined component.
And then there was another question around, I think the question is, how do you handle changes as a function of the lifetime of the project? And I know we've spent a fair amount of time talking about, our canonical model and how we track historical changes to the model as well as the data itself. So do you want to speak to that, Satya, that question?
Yeah, so is the question related to GenGraph or is the question related to the lineage? So, but I can speak to both of them. So, in the graph database, we can build actually complete history of all the documents and how they change over a period of time. So the only thing you have to do is the date when the document was ingested, and that date will act as a kind of a slowly changing dimension for your complete history of how the document changed over a period of time. So we have date as a property both in the vector database as well as in the graph database.
Yep. And then there's a follow-on question on how exactly is lineage tracked in the journey with metadata. So again, I think that could be a history question, a historical question. But go ahead, Satya.
Yeah, let me actually show that. So, here we have the impact analysis and we have the change history completely, So field lineage, if you see here, we have the flow diagram, which shows you at the highest level, and then you can drill down deeper into the next level, level 1 or 2. And the third thing we have is the change history. For example, it shows you, this all recorded modifications across systems detected by the change agent. So, and what is the impact of that change also we try to show you, So complete history of change is maintained and captured based on the date or timestamp from the code,
And then Satya, Julian had a follow up on, but why storing the chunks additionally in Memgraph? Isn't that duplicated data? Do you want to? Are we address that, Satya? I want to.
I think it is not. I think the whole point is graph database is not going to store the document itself and the chunks of document because it's not the right use case for it. But when you want to complete traceability and where did this information come from, you want to see the chunk of the document where it was written for explainability.
So is the point then physically we're not storing it in two places? You're storing it in Chroma and then propagating to graph when we talk about the chunks themselves.
And the graph has just the entities, nodes, and relationships. It doesn't have the details of the document in it.
Yeah, and I think that was Julian's question. So hopefully that helps, Julian. All right. How are we? What else, Satya? Are we ready to move to Q&A or?
Yep, I think we are ready to move to Q&A.
And Marco, we'll count on you to. I'm assuming we do Q&A through the text, but I don't know if we open it up to the voice as well. Go ahead.
No, it's mostly text. So if there's any questions, as we did, so thank you, Julian, and thank you, Charlie and Samuel for your questions. If there's any other, feel free to post them in the chat, and we'll get to them in the next couple of minutes. It's been quite a busy time with questions, which is always nice.
And then there's a follow-up on the legal domain accelerator that we can share. I think we can do that. Let's do that after the fact, Satya. That's probably easier.
Yeah.
But yeah, we can. I'm not sure who asked that, but we will definitely do a follow-up on that. Yeah, it was Julian as well. Perfect. Other questions?
I think you've answered. I think.
Yeah, no, this is really I really appreciate the ability to do these in line, and I was kind of just perusing them as we're going forward. But yeah, hopefully that's helpful. But yeah, I think the Marco, I don't know what the drill is exactly, but if there are follow-up questions, obviously you all.
Yeah, here is our email address. I will share it so that if you have any other questions, feel free to reach out.
Absolutely, no, happy to reach out or happy to follow up on any of these topics.
100%. And this call has obviously been recorded. We're gonna create a follow-up blog post and then publish it and everything, and definitely share the emails of the guys so you can get in touch. But yeah, there's one. Okay, so the document chunks are only stored in Chroma, and Memgraph just stores some entities like insurance.
Exactly.
Relationships, but without any document chunks.
Correct. Yep. And I think the other thing I was going to mention, Marco, the thing that would be interesting for us at some point is I'm super interested in hearing the community's perspective on their challenges, what their use cases look like, and we can certainly take that offline. But I think that's really interesting dialogue for us as well. So we can figure out how to do that later. I appreciate the kind of feedback in the community overall in terms of what they're seeing from a use case or technical perspective is super valuable to us as well. So
yep,
100%.
There's one more question here. Memgraph support fusion of vector index and nodes. Why isn't it used?
Yeah, that is certainly an option. Yep, absolutely.
Yep. So, and Mohammed had that question, and I think it's a good question. I think we haven't poked at that from our use case perspective yet, but to Satya's point, it doesn't mean that we can't.
Yeah, the reason I think we didn't use it because we started first with purely RAG option where we were using Chroma DB, so, and then we extended it to include Memgraph and graph RAG, so.
And Julian, you're correct. I think, that piece of, so the document.
Yeah, you are right.
In Chroma, that's correct.
Yeah.
Great. Well, thank you so much, guys. And thank you everyone who participated. This has been great. And again, really, really grateful for the guys to come and basically connect the practicalities with the kind of theory that's kind of sometimes out there, and to really bring it to life. So very thankful for that. We will have another community call with Previsant in 2 or 3 weeks. So stay tuned for that one. And in the meantime, have a good rest of the week, and we'll see you all on the interwebs.
Thank
Take
you.
care.
Thanks all.
Bye-bye.
Take care. Bye-bye.